All right, hello once again, Jeff Scott of Rankin Technical College. We've been going over the online PDF textbook, AppInventor2, Create Your Own Android Apps by Wolber, Abelson, Spurtis, and Looney. We're now up to chapter 17 of 24, which is on creating animated apps. This chapter, as it mentions, discusses methods for creating apps with simple animations. When you see an object moving smoothly along the computer screen, what you're really seeing is a quick succession of images with the object in a slightly different position at any time. That's what they're telling you here. With AppInventor, you program animation with ball and sprite components, which must be placed on a canvas, so the canvas must be out there first. All right, you move and transform these objects every successive fraction of a second. So in this chapter, we learn how the canvas coordinate system works and how you can use the clock.timer event to trigger movement, how to control the speed of objects, how to respond to events such as two objects crashing into one another. So you know what happens when you drag a canvas app or a canvas component out into an app. You put it in there and then you specify its height and width. All right. Quite often, at least with the width, you'll want it to be fill parent. Here's the canvas coordinate system. A drawing on a canvas is really a grid of pixels where position 0, 0, which we're used to seeing, the point of origin would be like, where the two lines cross, that would be point 0, 0. That is actually the upper left corner. As you move to the right, the x-coordinate increases. As you move down, the y-coordinate increases. As you move to the left, the x-coordinate decreases. As you move up, the y-coordinate decreases. Now remember, you can change the appearance of your canvas in two different ways. You can paint on it, or you can place objects within it. We looked at that paint pot way back in like chapter 3 or so, where we would bring an image in, and then you could, make colors on it and whatever. All right, placing and moving objects within it. Again, we went back and we looked at the ladybug chase, and there were one or two other ones that we did also. The canvas component provides the canvas.drawLine and the canvas.drawCircle blocks for painting pixels. We saw this again back when we looked at the paint pot example. AppInventor provides a palette of basic colors. We've looked at those. All right. We also looked at sprites mentioned on here. A sprite is a graphical object placed within a larger scene. In this case, in AppInventor, the scene is the canvas component. Both the ball and image sprite components are sprites. Their only difference is their appearance. Whereas a ball is just that. It's a circle that's typically some kind of color, or you might play with its radius. A sprite, on the other hand, is usually associated with some kind of an image. One way to specify animation is mentioned here in AppInventor is to change an object in response to a timer event. Most often, you'll move sprites to different locations on the canvas. You use timer events. It's the most common way of defining time intervals. Timer events are not triggered by the end user. Rather, they are indicated by the passage of time. It's a very important concept. Creating movement. To show a sprite moving over time, you typically use the sprite's move_to function found in both the sprite and ball components. And they show an example here. Move_to moves an object to an absolute location on a canvas, not a relative location. Speed. How fast a ball or something is moving depends on both the settings that you provide for the timer, interval property of the clock, and the parameters you specify in the move_to function. If you want a more smooth movement, you typically need a shorter time interval. All right. If it's a larger one, may or may not appear jerky. We talked quite a bit about collision detection. All right? And we've talked about that on more than one occasion. One of the last times we talked about collision detection was back in chapter 12 when we talked about working with the robots and having the collision detection at that time. So to create games and other animated apps, you need more complex functionality rather than just movement. AppInventor provides some high-level blocks for dealing with animation, such as an object reaching a screen's edge or two objects colliding. AppInventor typically will take care of this for you. Things like edge reached. If you want an object to disappear at the upper left corner each time it reaches the bottom or right edge, you could define it as shown on the page here. Colliding with and no longer colliding with. Again, games and other animated objects, or animated apps, I should say, often rely on activity occurring when two or more objects collide. For example, the no longer colliding with provides an opposite effect to the colliding with. It is triggered only when two objects have come together and then have separated. So they show an example of what you might want to do here. Both collided with and no longer collided with have an argument called other, which specifies the particular object with which you collided. The image sprite block is one that hasn't been discussed yet. This refers to the component as a whole, not a particular property of the component. When you need to compare components, in other words, to know which ones have collided, you can use this block. Interactive imagination, basically the stuff we've discussed so far, the end user hasn't been involved. But you may want to, if you're developing a game, you might want to allow, if you hold down harder on the mouse, for example, maybe you hit a golf ball higher. Maybe you make a person run faster or whatever it happens to be. Now you can specify animation without using a clock timer. All the animation examples we discussed so far have used a clock component to specify that an object should move or how far it should move each time the clock timer event is triggered. It's the most general method of specifying animation. You could also have it change an object's color or do something else. But if all you want to do is move an object, AppInventor provides an alternative that doesn't require the use of a clock component. Things like image sprite and ball components have properties for heading, speed, and interval. Rather than defining a clock 1 timer event, you can set these properties in the component designer or blocks editor to show how a sprite moves. Now they show a clock here, or I don't know what you call it, I guess the heading property. The key thing is this. If you set the heading to 0, the ball moves from left to right. If you set it to 90, the ball will move from bottom to top. If you set it to 180, it'll move from right to left, and if you set it to 270, it'll move from top to bottom. To cause an object to move, you also need to set the speed property to a value other than 0. The speed at which an object moves is actually determined by the speed and interval properties together. The speed property is a distance. That's pretty much it for this chapter. Again, the chapters are getting shorter and shorter. So as the author mentions here, using the canvas component, you can define a sub-area of the device's screen in which you want to move objects around and possibly interact with them. You can put only 2 types of components within a canvas, image sprites and balls. So animation in the end becomes, as it says, the act of an object moving or otherwise transforming over time. And there's different ways you can do this. We looked at doing it with the clock's timer event, but remember, if all you want to do is move the object, you have the alternative of using heading, speed, and interval properties together to image sprites and or to ball components. That's it for this chapter. So in the next chapter, we'll come back and go over chapter 18, which is programming your app to make decisions. And I'll be back with that shortly.